Hello folks, what we have today is the Team TRX404. This is on the CEPT band. Now, one of the first videos I did when I started doing this a couple of years ago was the Team TRX404 on the 2781 UK format band. And if I recall rightly, it looked like this model. But look, this is a TRX404 as well. And it looks different. Now then, let's have a look at the back. They've both got the selective calling sockets. We'll come to that in a moment. And they both come out of the same factory, haven't they? They both say made in Korea. Now, over the years, we've buying batches of stuff. I wouldn't buy radios on the CPT only band because we don't have any customers that use it. It's not very usable here in Lincolnshire. It's very noisy with foreign interference. The 2781 works better for us. But these have come in over the years, and about a week ago I did the servicing video on the realistic TRC 2005, which is CPT. So I thought, we'll have a look at the TRX404 Team, and then I discovered we got two. But that's quite handy because there's something else which I've bought along the way, and I bought these off eBay, and that is it the SR16 selcall units. I bought two of those from one deal on eBay, and these are the matching selcall units which will mate up to those radios. It says on the back for use with SR16 selcall. So we're going to have some fun playing with those. So when Mark comes over and does the field tests at the weekend, I'm hoping I've got two of these radios and two cell calls working. Now I'm going to open them up, we'll put them side by side and see if there's any difference inside. Well, they look identical inside, don't they? So I'm glad about that. I'd got fears that we're going to have to work out two lots of service information. I presume one's the early version and one's the late version, and I would suspect that that's the early version and that that's the late version, just the feeling I've got. Let's see if they've got the same printed circuit board identification, and they both say on the boards Team TRX404, so the board is actually made with this set in mind. So we have it on the right hand one and we have it on the left hand one. One thing I have observed, and noticing they use the LC7132 Sanyo channel synthesizer, is that I noticed what I expect is the IF subsystem chip there. On this which is the one I think is the earlier one, the MC3361, if you look there, it's a Samsung device. There's the Samsung logo. If we look on the other one, that's a Motorola one. Same chip, but one's made by Samsung and the other is made by Motorola. And with these being made in Korea, you'd expect them to be made by Samsung, with it being a South Korean company. Little observation there. So I managed to find a circuit diagram on the internet for the TRX404, and I noticed this was drawn in 1987, so that gives us a date. It's quite a complicated radio, so I presume it's quite a well made radio, and I presume it's quite a well performing radio. I've made myself a layout diagram of the adjustments here that I think we've got. Resistor 119 looks to me like it's cell core sensitivity, so we'll leave well alone on that one. But everything else looks straightforward. The synthesizer is an LC7132, so it'll be easy to find out which pin the lock detector is, and therefore how the VCO is set up. Although we don't have specific details, that will be something which would be look-upable. So we're going to switch this on, and the first thing I'm going to do is make sure it's on frequency, and just switch the power supply on. We're on channel 20, so we're on the CPT band, and so we're on 27.205, and I will be all poised to adjust the trimmer capacitor for the frequency. We'll just zoom in on that. They love putting things under wiring harnesses. You see the little green trimmer capacitor there next to the, with the crystal above it and the synthesizer chip to the left. That is C31, and that's how the frequency is set on this radio. So I'll just go into transmit, and it's 27.205.09, so that is on frequency without us having to adjust it. And without further adjustment, it's also doing just under 3 watts. Now, looking at what I've been able to determine from the circuit diagram, it looks to me like that could well be transformer 6. Because there's wax on the board, and because some of the parts are over the printed circuit board writing, because it's screen printed usually, we can't quite see, so it's a guesstimate that's T6. That looks to me like the early stages of the transmitter from the circuit diagram. But because we know it's transmitting, I'm not going to touch that. We're going to start with transformer 14 there. Now these are all filled with wax, so I have to get the trusty soldering iron onto it to melt it somewhat. So into transmit. That's now a full 3 watts. Move forward to transformer 13. Into transmit. Also a full 3 watts. Move over to transformer 12. A full 3 watts. Now the next two, L6 and L5, you've got holes in this screening plate, but the components are at an angle, and that is so frustrating. We've optimised that one using the yellow tool. Unfortunately, there's wax in that one, and it's on an angle, so it's a bit of a double whammy. I'll tell you what, I've managed to get it in. It's not, to be honest, it's only just doing just over 3 watts. But I would say that's a rather tight design to ensure that it can't be set up with illegally high power. What I would always recommend is you're going to go backwards and forwards over the coils to get absolutely optimum results, and that's something I'm going to do off camera. So having done that, let's see if we can set up it's fairy lights on this set, isn't it? And as we see, we've got a full complement of fairy lights. Now the adjustment for the transmit meter is resistor 46. Resistor 46. You've got this preset here, and then under the selcall socket, if I just tilt it, that one will be the receive one when we move on to it. So I'm going to do the transmit one first. We'll just set that. See if we can tilt it up like that. I want it just to be on 4. That's it. Next, we're going to get the trusty tone generator out. Hold that up to the mic. Go into transmit. Wallow. that is 1.5 kilohertz deviation, which is far too low. I have determined that resistor 122, which is, we've got 3 here, it's the lowest one of the 3, is deviation, and it is. I've just turned that up to full and we've just got 2. So we'll just see what we get with a whistle test to see whether that's how we would find that acceptable. Wallow. Wallow. We just get 2.2, so it's just within what we would believe to be acceptable. Again, they've manufactured this set with very tight tolerances, so it can't be set up to operate illegally, which is good. I remember some of those Amstrads which you could set up the deviation so high that you could end up talking on 3 channels at once, and that really wasn't good planning. So, to be honest, that's it, isn't it, on the transmit side of the radio? Yeah, that's covered everything. So just to recap, we're setting the frequency with capacitor 31 there. We've got transformer 6, which is under the wiring harness there, which is the early stages of the transmitter. I've just checked that. We've got transformer 14, 13, 12, 6 and 5 under the can, and they're on a bit of an angle. They're all got wax in them, so they're a bit of a pain, but at least they will stay put. We've got these parts of the transmitter here which don't have cores in. Don't think for a minute they're missing. That's how they are. By going through this several times, we've managed to get just under 3.5 watts. But as I've said many times before, if I put that on a CB type power meter, it's probably doing about 5. Then we're setting up the RF power meter, the fairy lights, with resistor 46 there, and finally the deviation with 122, which is that one there. So we've got the factory original mic on this, although it's seen better days when you look at somebody eating the button off the back. So there you have it, the Team TRX404 from 1987 on the CPT band.